Hi class, welcome to lesson 28, Periodic Trends. This is the final lesson in Unit 4, the periodic table. That means you will have a test soon. As you will follow along in this video, make sure that you are taking notes and writing down questions as you go. Bring your questions to class and we'll work together to make sure we really understand the trends of the periodic table. In this lesson, we will describe the periodic trends for atomic radius, ionization energy, and electronegativity, and we will compare the radius of atoms and ions of both metals and nonmetals. A periodic trend is just a general pattern. The three periodic trends that we are going to be concerned with are the trends in atomic radius, first ionization energy, and electronegativity. The good news is there's no need to memorize these trends, as for every test you'll be given a Regents chemistry reference table. On reference table S, you'll find the data you need to locate the trend. The atomic radius is just the distance between the positive nucleus of an atom and its outermost negative electron. The stronger the nucleus, the more pull the outermost electron will experience. As we move across the period, we gain nuclear pull as we add one proton, but we don't gain any principal energy levels. Therefore, our atomic radius decreases across the period. As we go down the group, we add more principal energy levels. So the nucleus has less pull and therefore atomic radius increases. Here's a general picture of atomic radius. Again, don't memorize the trend, just look it up on reference table S. Here is a practice Regents question for you to try. Look up all the atomic radii on reference table S. When atoms form ions, their radii change. Now remember that atoms gain or lose electrons to obtain stable noble gas electron configuration, which typically is a valence of 8. Remember, 8 is great, but 2 will do. Metals tend to lose electrons to form positive ions, while nonmetals tend to gain electrons and form negative ions. You can find the ion charge in the upper right-hand corner of each cell on the periodic table. So here you can see that metals tend to lose their electrons as they form positive ions, also known as cations. Cations are smaller than the atoms they come from. So we can see that the atomic electron configuration of sodium has 3 principal energy levels, but when it forms an +1 ion, it loses 1 principal energy level, thus making the ion smaller. If you lose anything, you're going to be smaller. Also note in the Lewis dot diagram, the sodium ion has 0 electrons. We want to show that its original valence of 1 in the 3rd principal energy level is vacated, so it will have no dots. Nonmetals do the opposite of metals. Nonmetals tend to gain electrons, making negative ions, also known as anions. This makes them larger because they are gaining. Let's look at an example of chlorine. Here you can see how a calcium atom must gain 1 electron to form a calcium ion. The nucleus gets no stronger as the nucleus remains a positive 17. So a positive 17 has less pull over 8 negatives than it does over 7. So as we gain electrons, we gain radius. Answer this Regents question about ions. Remember, ions come from the gain or loss of electrons. Mass is due to protons and neutrons. Answer this Regents question. Look back at your notes as we've just discussed chlorine atoms and ions. The next trend we're going to explore is electronegativity. It is important that you know or memorize the definition of electronegativity. Electronegativity is the ability of an atom to attract electrons in a chemical bond. So electronegativity is the ability of a positive nucleus of one atom to attract the negative electron of its neighbor. Electronegativity is demonstrated here, as it is the pull that fluorine exerts to gain sodium's electron. The definition of electronegativity can be understood by breaking down its word into the two words it represents. It is the strength that an atom exerts to gain an electron to become a negative ion or anion. We know that atoms are neutral because their protons equal their negative electrons, but electronegativity is the amount of pull an atom has to gain another atom's negative electron to obtain an ion with a negative charge in order to complete its valence shell like a stable noble gas. As we move across a period, electronegativity increases because nuclear charge, or the number of protons, increase. More protons means more pull of electrons from a neighbor's atoms. As we move down the group, electronegativity decreases. That's because as you add more shells to your atom, your nucleus has to pull through all of your shells before it can pull on a neighboring atom's electrons. Look at this practice Regents question. It asks you to identify an atom's attraction for electrons in a chemical bond. Of course, you know this is the definition of electronegativity. Now it is your turn to try one question on your own. Make sure that you're looking up data on reference table S. Ionization energy sounds like the opposite of electronegativity, but because we have a double negative, ionization energy and electronegativity are very similar. Ionization energy is the amount of energy needed to remove the most loosely held electron from an atom in the gaseous state. Remember, the protons in the nucleus are what hold electrons into an atom. As we move across the period, we are gaining more protons. Since we're gaining more protons, we're holding our electrons tighter. Therefore, our first ionization energy increases. As we move down the group, we're adding principal energy levels. There's more shielding or things in the way between the nucleus and the outermost electron. Therefore, as the atom gets larger, its first ionization energy decreases. Remember, for all periodic trends, the best technique is simply to look up numbers on reference table S and compare them to one another. Don't memorize the trend, just look it up. Here is a quick summary of the periodic trends. The arrows point to the highest values. Again, don't memorize the trends, just use your periodic table and reference table S to look them up. Stay tuned to watch Sydney show us the difference between electronegativity, or gaining electrons, and ionization energy, or losing electrons.
I'm going to show you about ionization energy.
And I'm going to show you about electronegativity. I got to do it again.
I'm a sodium atom. Look at my electrons. 2, 8, 1.
Hey kid, give me your electrons.
My mom said I should have a valence of 8. Here, take 1. I am chlorine. Look at my electrons. 2, 8, 7.
Hey kid, give me your electrons.
My mom said I should have a valence of 8. I don't want to give you any of my electrons. I'm cesium. Look at my electrons. 2, 8, 18, 18, 8, 1. Oh my, I have so many electrons, I can barely hold on to them.
Hey kid, give me your electron.
Oh, my mom said I should have a valence of 8. Here you go.
This is the final video lesson for Unit 4, the periodic table. We still have one more class lesson on trends in chemical reactivity. Expect a test and a quiz soon. I hope you enjoy my awesome chemistry jokes. Bring your questions to class. See you soon.